Hi everyone, it's Nono here, and I want to welcome you one more week to my live stream. This is a space that I reserve weekly to do creative coding and machine intelligence. And we're gonna get started really soon. So hold on with us, and I'm gonna tell you about what we're gonna be doing this week. And yeah, we'll get started. I'll be right back. And one notice, if you're watching this on the recording and not live, you can browse through on the video timeline and you might find timestamps that will let you skip the boring parts and go to the interesting bits. Okay, so we're gonna get started now, and I'm gonna tell you what we're gonna see today. Let me pull my stuff here. All right. Again, it's Nono Martinez Alonso here. If you don't know me, you can watch a lot of previous live streams on my channel, and we're gonna get started. I'll ask you to like this video if you want to support the work that I'm doing here with the tutorials and the live stream, and to subscribe if you want to get notified when I go live next or when I upload new videos. You can join the community. We have a Discord server at Nono.MA Discord. It will direct you to the invite, or you can go to that QR code and just access the same link. Last week, we took a look at Pixel2Style2Pixel. This is a neural network that we're gonna try to take a look at today. You can go and watch that video in the channel. And as always, you can submit questions about the latest episodes of Getting Simples or any previous episodes at gettingsimple.com/ask. We're going to skip again the goals, so we're focusing again on the intelligence and sketching playlist, working sessions toward a collaborative AI platform or sketching platform. And we're going to jump straight ahead to what we're going to be working on today. Today, we just have one item, and is that I want to learn how to train Pixel2Style2Pixel. We already started that last week, that work, and we have a few slides that talk about this. We're going to take a look at them right now. And yeah, hopefully over the next live streams, we manage to train this network and be able to train it with custom data and generate images, because I think the architecture in this, so the contribution with this neural network is really cool. All right, let's record an intro to the work session and get started. Hi everyone, it's Nono here, and this is one more work session of the Intelligence and Sketching project, in which we are building a collaborative AI sketching platform. We'll make it open and let other people adapt their bots and draw together with humans and machines. More specifically, today we're taking a look at Pixel2Style2Pixel. We're going to try to see how to train. So let's make a quick, let me switch off this thing here. I'm going to record a better intro to this. So, okay. I hit the camera. Things of live streaming. All right, let me see how I can do this. To place the, I'm trying a new setup, so this is something that I hadn't tried before. Let's see what this is. Okay, I think it should be fine. Cool. I think that should be okay. All right, so let's record our intro. I think there is some noise here on the webcam. So I'm trying a new setup, and I don't think that I got it right still. Can see if that works better. All right, it seems like it does. All right, let's get back at it. I'll try not to hit that again. All right, so let's record an intro here. Hi everyone, it's Nono here, and we're going to take a look at how to train Pixel2Style2Pixel. Let's see if we can learn how this network is trained and how we can prepare our own dataset to train our models. Okay, so last week I showed things, some GIFs that I have produced with pre-trained models, and even this video. Hi everyone, it's Nono here, and this is a test of Pixel2Style2Pixel. So in livestream 48, I talk over these ones, and we have a few slides here that talk about nodes of pointers to what we saw last week, or where we were, right? So we're gonna get back at taking a look at this. What we saw is that there were some nodes on how to configure this network to be trained, and I still can see some noise here on the screen. I don't know why that is. Let me adjust this. Okay, so you can see, I don't know. Okay, so I guess I can show you what I'm doing, so this is a bit less boring if you're connecting live. So I'm here, and I'm trying to reduce these noise edges, which might require some ambient light on my end. Let me check. All right, I think that should be it. Cool. I might be able to open it here. All right, then we got it. Great. So we were here. Let me open back the chat. Hi, I want to say hi to Sajay Kumarji and Rob Beal for connecting with us online. So it's good to see familiar faces, and it's great to have you guys. All right, so let's just jump ahead and try to see what they have. So they, the one thing that we saw last week is that they do have sketch simplification. So these are some algorithms that they were using from these separate repos. So Boben's sketch simplification, and this is because my interest with Pixel2Style2Pixel is actually to build a to build a data set that we can use for from mapping line sketches into textures or generated images. Okay, so we do have this here, and I see there's some people connecting online, so I will say hello, and you can say hi if you feel comfortable on the chat. Let us know where you're connecting from and how you found us. All right, so let me zoom in a bit. We've seen these a few times before, and we're just gonna go straight to the training instructions, right? So they're saying, okay, you have to prepare your data, and then you gotta run the training script. Frontalization, sketch to face, training the pSp encoder. Encode. Frontalization. Okay, so I'm gonna open my Google Colab account. So so this is weird because I created a new Google Colab account. So I signed up again for Google Colab Pro, but I did with my personal email, and I created an email specifically for this live stream. So I probably should have done that with that address, but it's okay. Let me see. Hello, Vitor. Nice to see another familiar face around. Okay. So now we're back to doing some machine learning. At least today is fully gonna be machine learning. So I'm gonna leave aside a bit the React part, but we'll come back to it because we need to finish the the first part of the project. Okay, I guess we'll just go here and give me just one brief second. Okay, so for those of you who are online, have you played at all with Pixel2Style2Pixel? Have you done anything with it since we started taking a look at it on the live stream? Okay, encode. So I guess one thing we need to understand first is what the encode model is compared to the other models. Let me write here some notes. So this is live stream 49, and we're gonna see that a part is like, what is Pixel2Style2Pixels encode model? And today I have, as I said, a new setup. So I have I have a camera here that is a video camera. It's not the normal or the usual webcam, and I have a light ring here that cannot be turned. I cannot set it to be lower light, and it's actually killing my eyes. So probably not the best setup. I need to take a look at some other alternatives. All right, so part of this repository. Yeah, let's just take a look at where they explain what the encode model is. Probably on the paper. Yeah, if any of you has bandwidth to take a look at some of these things, that'd be good if you can follow the paper along the while I'm doing this. But meanwhile, I'm gonna do it. Okay, I already have this paper downloaded. For some reason, it's taking really long. And pSp pixel to style to pixel. Right. I didn't ask, but can you see me and can you hear me okay today? I guess you can. Okay, there we go. Okay. Okay, I guess what they call encoder is a inversion, so StyleGAN inversion. Model StyleGAN inversion. We start by evaluating the usage of the pSp framework for StyleGAN inversion, that is finding the latent code of real images in the latent domain. We compare our method to the optimization technique from Karas et al., the Ally encoder, and to the decoder from IDinvert. The Ally method proposes a StyleGAN-based autoencoder, where the encoder is trained alongside the generator to generate latent codes. In IDinvert, images are embedded into the latent domain of a pre-trained StyleGAN by first encoding the image into W+, and then directly optimizing over the generated image to tune the latent. For a fair comparison, we compare with IDinvert, where no further optimization is performed after encoding. All right, so this is what I understood last week, or last time I read this paper, is that what their encoding network does is that you input a raster image, and then you get the W plus latent vector, or what they call it. The encoder is trained alongside the generator to generate latent codes. So latent codes, I guess they're talking about the 512 components that you need to input StyleGAN in order to generate an image. So we're going to copy this into our slides just so we build an intuition of the things that we learn here. All right, we can delete everything else. All right. Okay, so we do, let me see. All right, so let's highlight probably. All right. Cool. I think this is fair to say, right? So StyleGAN inversion is finding the latent code of real images. StyleGAN inversion is finding the latent code of real images in the latent domain. The difference between this network and the ALAE or ALAE and the ID invert approaches is that no further optimization is performed after encoding, right? So that's the main difference in there. And you know what that means is that they're able to grab an image and then convert that into an input of StyleGAN. Okay, it's kind of like reverse engineering or inverting, right? What you need to input StyleGAN to give you a specific image. So it's more like, let's see, so we get a diagram here. It would be, and probably the remarkable tablet, the whiteboard like approach would be useful here, right? So just to make this quick, we need to make these diagrams better. All right, so here we'll have okay, and actually what I'm trying to do there is probably this. So okay, so now I remember there are two. So this that I'm describing here was the Z vector, which has 512 components. But actually, what you have to what this is calculating is not that one, as I see from the diagram. Is the W plus. Which seems to have from W1 to W18. All right. Oh, another. All right. Let's get one of those randomly sample latent. Okay, but here it does say 1 by 512. So each of these is a Z vector. Style mixing for multimodal generation. Okay. Figure 4 shows a qualitative comparison between the methods. One can see that a line method operating in W domain cannot reconstruct the input image. Right, let's see figure 4. pSp. Whoa. Well, pretty surprising results here. Okay. Okay, so all right, so let's leave the paper aside for a second and come back to the code. So we were gonna create a notebook for this project. Download model command. So download pre-trained models. As part of this repository, we provide pre-trained models for each of the above experiments. We'll download the model for the selected experiments and save it to the folder. So this is just for inference, right? So for training, we probably need to resolve a lot of dependencies. New notebook. Okay. So nothing fancy here yet. You're just going to copy the same approach to clone the repo. Make sure we have GPUs. Okay. And I don't know what Ninja Linux. I'm not sure what Ninja is used for. we'll see. We might not need this. All right, so in this notebook, so we've cloned the repo. We have everything here. And let's see what this says here. Environment. Running is a all dependencies for defining the environment are provided here. Okay, so let's try to go ahead. Let's see what fails. So let's actually just try to run this. Batch size, workers. Doesn't say how many epochs to train for, right? Intermediate training results are saved to all there. This includes checkpoint, train up, and test up. Additionally, if you have TensorFlow installed, you can visualize logs. Right, so let's go into the train endpoint. Not here. So this is scripts training. Train.py. Okay. Batch size, no epochs. Okay, let's add this here. Max steps. We're just gonna put 1000 because okay, this is not gonna work, but you know, we'll just try to see what happens. Oh, okay. Pixel2Style2Pixel. So we change directories. We can see we're there like this. All right, so we change directories and then we try running this. I mean, we don't have any dependencies installed, so this probably is not going to work. I mean, it would be really weird if it works without doing anything, but let's see what this complains about. All right, so Ninja is required to load C++ extensions. Ninja is required to load. Okay, now we know what Ninja is required for. So we do this, we put this here, and then we install Ninja. Okay, let's try again. So we have a set of frozen dependencies. Let's keep this open so we know. Maybe just put that as a note here. All training training options are located at path to StyleGAN model weights. Path to pSp model checkpoint. Pre-trained models, model IR. All right, so let's follow the instructions, right? Let's take a look at the training instructions. So the main training script is here. Intermediate training results are here. Additionally, if you have TensorBoard, you can see here. This is how to train, but how to set up. Conditional image synthesis, no identity loss is utilized. Identity lambda 0, super resolution. See train options for all training specific flags. Test specific flags. If you wish to resume from a specific checkpoint pre-trained pSp model, you may do so by using checkpoint path. Checkpoint path. Are we doing that? No. So checkpoint path. No. Okay. We assume the StyleGAN used outputs images or resolution, blah blah blah. If you wish to generate images from segmentation mask, please specify this. For generating from sketches, please this. Specify level and C will directly be used for RGB. Identity loss, encoder, or editing. Testing, all right. Metrics. Okay. Okay. So let's see where this file lives. Pre-trained models, model IRSE50. Get download model command. Is that here? Okay, pre-trained IRSE model taken from 3BN for using our 1D loss during pSp training. Okay. Okay, so that's here. Cool. And from Google Drive, so we can download that directly from Google Drive. Let me take a look. File ID. These are the pre-trained models. Okay, let's see the safe path here. Pre-trained model. All right, yeah, so that seems like it would work. If it doesn't exist, we create it. And get download model command. Okay, let's try this. Get download model command, some ID here, and my file name. Cookies. Okay, I think this might be for downloading the pre-trained models, but not to download this file, which is just like a normal file on Google Drive. Okay, so let me open a different notebook just to make sure that StyleGAN 2. Yes, this is from live 24, so it's more than 24 live streams ago, and we have a tutorial on how to train StyleGAN. So here I have some code on how to download. So probably just is the simplest thing that we can do here is okay. So here we just need to put file name, URL, and we'll do here save path. All right. So here's our model download commands, right? So if we run this, and all we have to do now is execute that command. So just put here download command. We probably want to do it something like this. and we just run download command, and wget not found. Wget. All right, I think I'm gonna spend here half an hour more working on this. We'll see how far we get. This is gonna be a long run effort. Okay, so I put this here, so we don't need to put that sign in there. That's the failure point. All right, so this probably gonna download there. We don't have the bar here, so probably just do save path. We do another all right, let's try that one, and that seems like it. We downloaded this here, but we're gonna delete it, and we now have this folder with our model. Check this out. All right. Once more. Okay, and now we execute this one. And our model is here. All right, so one less error that we'll get while training. So we need to put this above here. And this is gonna go up. All right, so we try to save again. Yes. All right, so we are going to get the model now. And we have this, so we download, let's add a note there. So this is gonna be, we're gonna add now the name of the model and some instructions there. All right, and now we run this. I mean, we're gonna get errors, I would expect, again and again, but we're gonna go building. Oops, path to experiment already exists. Okay, so experiments 01. See if there's anything there. Path. So training groups. I guess that's outside of here, so I'm just gonna make here experiments 01, so it's relative to this directory. Okay, experiments 01 opt. So we're creating this set of options that we're getting printed here. That's the config of our training run. So from here we can see what's being used. The StyleGAN weights, we haven't downloaded this one. And I guess we do need, where are the StyleGAN models? This is the, okay, so here we gotta download this one. Okay, so they're using these keys, I see. So instead of passing the URL, so the Google Drive URL, they're using just the file key, which is okay. We can do that as well. So we can, how are they calling it? File ID, okay. I'm fine with that. So file ID, and then we do URL equals this, and this is file ID, and I guess this is the command. All right, so in here we just provide the ID, and let's leave it like that, it's more readable. And we're going to do the same, so with this key, that is the train StyleGAN model. Okay, we need another name for this, which is above here, is the one that is specified there. So we update this name here, and then we run this to download the model. And we should have that now. Unable to resolve host address. Alright, okay, we need to rerun this and that to define the function again. So now in pre-trained models, we also have this StyleGAN checkpoint. Okay, so let's see what else. What is failing here? Unpickling error. Okay, let's run this again now that we have that PT model. Oops, experiments already exist. Okay, let's just do experiment 2. All right, great. So open file, blah, blah, blah. Value key, this is at serialization torch, torch load, train 32. Okay, train 32. Train 32 main, then here, so coach, and then the coach is failing. So training coach, and it's in line 36. pSp line 56. Torch load model paths. All right, so model paths doesn't exist here. So model paths, path. Loading encoder waits from IRSA 50. Okay, so model paths. Who's providing the model paths? That's hard coded. Okay, well, what is this? That's cool. Okay, so let's go to models, pSp, and let's go to line, was it 56? Yeah, okay. And who is, so model paths, where does model paths come from? Model paths, that's being assumed as a global variable. Model paths. Paths config. Okay, so that's what they mention. PTH is here. Let's just try that locally. Let's see if we get the same error. So I'm gonna quickly go to desktop, create an environment that is gonna be called live 49, and we're gonna have IPy kernel. Let's see what Python version we have here. Python version 3.7 equals 3.712. Wait, and then we're gonna say yes. Right, inside of this Conda environment, I'm gonna install Torch, because that's what we have. So Conda, oh, not found. Okay, let's just do this. Inside we'll run something like this in Torch, and maybe we need Torch Vision. We'll just load this. And yeah, we gotta do here Conda activate live 49, and then inside we'll do the install command. All right, so I'll do the pip install torch right now, and we're going to all right, so that's install torch, and what I'm gonna do is I'm gonna try to download the same model that we have. Oh, hello, Juanda. Glad to see you connecting online. We're doing some machine learning experiments today, trying to see if we can learn how to train or make a notebook to train Pixel2Style2Pixel. Okay, so we have here this command. Okay, let me take this down and close this. So we have here a command that we're building for this. So it wouldn't help, so it wouldn't hurt to print this command here. So you can reuse it. Awesome. So we're on the desktop, so I'm gonna go to a temporary, well, actually, yeah, actually we can make this to post it later. This is Pixel2Style2Pixel Training. Okay, so I'm gonna make a script just to make sure that we are doing this okay. And let's just call it script, and we're going to, well, this doesn't go here, so we're going to import Torch here. So let me first download this here. So we're gonna download the file, the model file here locally. And just so you see, we do have the model here downloaded. We can open it with Netron. Okay, so maybe this is not downloaded properly, and that's the problem. All right, so this is an HTML file. Okay, I see. All right, so let's go back to the StyleGAN notebook that I had to see how I was downloading these files before. So the error that we're getting, and I now know what it is that when this line tries to load the model, which is probably in the right location, is finding this caret as the first character of our file, which is not wrong. I mean, it's exactly what the file has at the beginning, right? So this is an HTML file. Yeah, which, let me. This is the first character of that file. Hi, Bea. Nice to see you connecting online. Okay, let's keep going. All right, how was I constructing this network? Network. Okay, so so yeah, we probably do need this method as it was initially. All right, that seems like it works. All right, at least we learned something, I think. Okay, so we got the and I see that there's people connecting online, so I'll invite you to type and say hello on the chat or tell us where you're connecting from. So yeah, I get here these models. So I guess we don't need to test anymore, but I'm going to either way close some stuff. And this is cool because now we have a method to download files from Google Drive, which I tried to do before, but I didn't manage to. I'm not gonna take a look at that now in detail. Seems like it's loading cookies. I don't know. Keep session cookies. Some hacking there. All right, so we have that and we can now run this. On the meanwhile, I'm gonna copy this command. And download the model locally as well. All right, so let's remove this part here. Okay, so this is probably using the remote session of the notebooks, and that's why I cannot really do that from here. So long story short, take this out. Okay, great. So what is failing here now? Oops, this already exists already. Okay. So once more, we're testing this notebook here. So trying to see loading encoder weights. All right, so it seems like now the weights are gonna get loaded. Loading weights from pre-trained. It's now downloading AlexNet as well. And we got an error, right? What is that error now? All right, is not a valid directory. There assert data utils images dataset source root in dataset for FFH encode dataset. Okay, so we haven't really put our dataset anywhere, so that's something we could expect to fail. So I'm kind of going backwards and trying to see error after error to see, because there are no one by one, like line by line instructions that I can follow. And yeah, we have the so the data set. Okay, so data sets, pre-trained models. So we don't have the data sets. So these are the pre-trained models, but what about the data sets? Augmentations, GTREST dataset, images dataset. Okay, and inference dataset. Make dataset root. Okay, so data utils. Okay. So from utils, data utils, make dataset dir. Directory asserted there is no valid directory. So I haven't provided any directory. So where is that provided? So this is make dataset. Source root. Source root. Images dataset. Okay, so that is in coach, in configure datasets. Self. Train source root. All right, so dataset paths FFHQ. Dataset paths config. And this is what's not defined. All right, so FFHQ. Okay, so I guess, so this is 70,000 images. And right, so let's try with a few of them. All right, so it's almost 7:30, so we're gonna have to wrap soon. PNGs. Okay, so let's just try. So these are 1,000 images. We just get some. Download. Okay, so we have a sample data set. I don't know if this is gonna be enough for us to train, but for now, I'm gonna try to see if this unblocks us. So the first thing is I have to go to my paths config, an update here that this is going to be data FFHQ. All right, we'll just save that, and on the meanwhile we'll run this just to see if that actually takes effect. And I'm gonna create that data directory. All right, let's do 4 here. So new folder called data. And here we're gonna drag and drop our zip file data. Right, so it's not a valid directory. Not yet. So new folder hhfq. So this seems like it might have been, it's still uploading. You can see below here the file that I dropped, and now we have the, so what do you say, ffhq. So this is high quality, Flickr faces high quality, and we're gonna have to wait until this completes. It seems it goes a bit slow. Maybe there is a way to download just this folder, get link. Copy link. Is this something? Where we can download? Well, maybe we copy. So it's like around 1.25 by 1000. That's 1 gig. We could probably just copy a few of these to my Google Drive. FFHQ. All right, so we are going to get the date, time. Okay, I'm gonna get a helper method here. So above here to put our date, so we can say that our current date is this. Yeah, that's gonna be let's see if this works. All right, not a valid directory. So okay, let's try to run this. Okay, so now we're getting unique names for the experiment folders, which seems better. Let's see, so make dataset that's on utils, data utils, and we have make dataset, right? So let's first try to print. So dir is empty, right? So I don't understand how this happened. ffhq ffhq ffhq. I don't understand. Paths. Okay, dataset paths config. That's not it. Dataset paths. Dataset. So test source root celeb a test. Okay, so I guess what's going on is that we not only need to set that, but so we have a ffhq encode, and that is ffhq encode, so that's using ffhq and celeb a test. So we do need to celeb a test. It's going to be also ffhq. And okay, so we have to override the dataset paths for celeb a test and ffhq in configs data, no, so paths config.py. Yeah, I'm writing that here so we have a place to, so some notes for later. All right, so let's close these things. I think we're not going to get that error now, so we might get another error. We probably will, but we can see what it is. All right. Num samples should be a positive integer value, but we got num samples equals 0. All right, so that means there's no data set there. Not sure if I can open, what is this, code snippets. Can I open a terminal here? Okay, maybe not. All right, so we are gonna go to, so let's see where we are. So we're in directory, and we're gonna go to data, and we're gonna try to unzip. So we're gonna move drive, download. So let's rename this first. Move this into ffhq files.zip. See what happens. Right, so Oh, it's not uploaded yet. Okay. I don't know if I broke it then. Okay. I think so. Last time the fast thing to do there was to upload to Dropbox and then download directly from Dropbox. What can we do? Yeah, I don't know. I mean, this is still taking some time. Okay, let's see. Okay, let me see if my computer doesn't go too slow. All right, and what else? Okay, so this is uploaded now. Let's see if this works. Valid. Possible zip bomb. Okay. I split the file in two. Okay, we're just gonna delete this. Okay, so the file is now in Dropbox, so I'm just gonna copy the link. Try to see if we can download that. All right, that's a lot faster, as you can see. All right, so we have the files there, and now we can go into that directory and unzip the files and see what happens. Oh, download again. All right, well, we have those files, and I guess we could remove files outside. Okay, so we have the images, so let's go and try to train again. There's a way to make this silence, but not know yet right now. Okay, so let's try this out. Let's see if this works. And yeah, are you guys following? Is this, this is one of those sessions where it's slow because there are many errors and many things that don't work at the first time. So we're slowly figuring out how to do it. But in the future we'll have a smooth video. on how to do this. And this has 100 samples, and it seems like we're training. So this might be close to a good point where we can leave it today. All right, we have logs. We have, so I'm looking at here. You might not see with my head. So we're looking at this experiment, and we have checkpoints, we have logs, we have images, and we have a TensorBoard events file, which is it's really good news. So these test phases, where are they? Input, target, output. Input, target, output. Nice. I mean, this is cool. Right, we're training, and so this is doing the entire loop. So this is actually testing the encoder with the StyleGAN network afterwards. Right, and we got an error. CUDA out of memory. Try to allocate 1 megabyte total capacity. 14 already allocated. 14.21 gig reserved. All right, is this the high RAM runtime? High RAM. Okay. So we are. So the only thing that we have here that we shouldn't reclone, because we already have edits. So restart and run all. Yes, let's see. So let me see, we can take notes of what we've done. Okay, so we did write a training notebook for Pixel2Style2Pixel from scratch on Google Colab. We've this notebook clones, so we clone the repository, the GitHub repository. We override the dataset, blah blah blah. We download the models. What else? And then we run the scripts.train.py file with the FFHQ encode configuration. Okay, so those are our notes for today's live stream. Let's see where this is. Okay. All right, I don't know what's going on here. Cell is already running. All right, let's restart the runtime again. And block this re-downloads. Okay, whatever. Run all. Okay. All right. Invalid key. StyleGAN FFHQ. Not sure. Now the other one is failing. This is not a good method. Right, now it's downloaded properly. Okay, now this is gonna run. Let's see. All right, I have 10 or 15 minutes. Okay, so here's delete and no such file. It's not even there. Okay, and here. Okay, so this is now training, so we might get some other error, but hopefully not an error from our machine running out of RAM, because you can see there that we have still 22 gigs available. And I don't know how long this is gonna take. I'm not training for too many steps. This is step 0. I don't know how often it jumps. So we've said that, oh, another error. Try to allocate 1 megabyte. Already allocated. That's a bit weird. CUDA out of memory. So we might not be doing the data allocation properly. There might be something auto reload. Haha. CUDA. What is net CUDA doing? Yes, Rob, it's a bit frustrating, but it's a problem when they don't provide directly a notebook and or like proper instructions. So maybe we could, one thing we could do, we could contribute and rewrite, like make a pull request to rewrite the training instructions at least, or at least to provide a notebook that allows somebody to just get going with training. And once we start training, I think we can, we can start thinking about creating our own data set and seeing how that performs. Okay, so yeah, let's see if we can make that contribution happen. Encoders, let's see. Encoders. How does the network doesn't have anything to do with CUDA, and CUDA is here? CUDA inference. CUDA device. First stage. Okay, Google, Colab, CUDA memory device, Torch. Let's try to see CUDA memory, Colab, Autograph. Nothing is mentioned here about GPU memory. All right, let's see this. So I've tried this. I don't know if that will solve it. Probably not, but you know, it doesn't hurt to try. Let's see. All right, while this is running, I'm gonna take a really quick break because we're gonna wrap up really soon, but I'm gonna leave you with this. Yeah, maybe, yeah, I'll leave you with this and we'll see what happens in a second. I'll be back. Okay, I'm here. Let's see what happens with the training. We got an error again. Okay, so again, memory of Okay, yeah, this is one of those bugs that we're not gonna be able to resolve right now. This is the same. Main runtime, just reset the process to resolve this issue. Right. Okay, we can do one last push. So we would have to automate everything just to try that. So we would download from Dropbox as well. Would have to make this there, make there data ffhq. Yes, so that would work supposedly, and then in config, path configs. So we need to try to see if we can do set I don't remember how this is used. Okay, let's try that locally first. So if I have a file here, test.x ffhq set, and then we do here I think something like ffhq to something. Oh wait, test.txt. Okay, so that would be, we would need to do, this, right? So we'll put here this. Okay. So we're trying to make a pattern to automatically, after we clone the repo, we automatically want to replace certain variables in there. So we are, we're going to, let's see how we do that. Let's just, cat test txt and set. Okay, so we're converting that to that, and we're gonna do this to ffhq. Awesome. Nice, great. So with this command here, we are replacing that, and now we need to do the same for celeb A train, but we want to do it on the file, and I think for that we need a flag, and I think I do have an example for that. Set I, right? If I do set I, so let's first open this. So I'm opening here, so these are contents of test.txt, and if I run, right, when I run this command, okay, so this is the pattern. Okay, so let's try again. So we're replacing this with, so we're adding something here automatically. So I have this in Visual Studio Code, I click, oh, not yet. What's different here? E. S. All right, let's try to do this. I think this might work. All right, trial and error. Boom. Undefined label test. All right. All right, so this is how we do it. So we first print what's in there, and then we change that on the contents of this file, and we save that to the same file. Doesn't work. Oh, HQ, data HQ. Let's see. E. New txt. Okay. Well, let's try to see if this is something that we can get done quickly now that we have this. So we will have this, right? So we would have this, and this would be empty. This would be empty. And the goal is, so if this is original, the goal is that we do that on original, and then we get this out. Okay, out. Great. Okay, so we can do this, but now we need to also do, so now we do remove the, so now we, okay, so this is the original. So what we're gonna do is copy the original to in.text, and then we do this thing. Then we put that into out, and we need to, well, we're gonna do that. So we have original, we have in, so this has to be in. Can we do that twice? and now it's celeb_a test, celeb_a test. Can I do okay. All right, so I think I got it. We're going to do this, and then we're going to save that into output.txt. All right, so now we just need to recover what we did before. So this here, and this other one. All right, and now this command. So, all right, so we are going to hope this works, and that this works. All right, let's see. Why doesn't this work? Okay, the one in the bottom works. Okay, so all right, and great. So now this works, and great. Original txt. Okay. All right, so what we're gonna do is that we're gonna assume that there is somebody providing the data set paths, which is a data config path, the py, config, so data, so this is paths config, paths config.py. We're going to move into temp, and then we're going to do get temp, and we're going to save that into paths config.py. See if that works. And we're going to copy original.txt to paths config.py. And here we'll remove them. Okay, let's try that. All right, so imagining that okay, so now we imagine that here we do have this file as it originally is, and we run our command. So this is path config, so we just need to do this part here. Okay, great, so I just run these commands. All right, and that shows up perfectly. So now the only thing that I need to do is to make these paths. So where is that? That is in configs. So we're just gonna go here and say, okay, so we're gonna need this. Okay, so just configs here and configs here. Great. All right, so this should work, hopefully. If it doesn't, we'll keep working on it. All right, so we do git clone here, we do get this, but after here we override paths config.py, and this is all this. So can we do that? Can I do echo hello there? No, okay, so just to avoid errors with that, just gonna make this a one-liner. Okay, that should be all that I've done to customize this. And I'm gonna do this factory reset runtime. We're gonna change the runtime, we're gonna keep it the same. Connect to a runtime, reconnect. Okay, let's see, run all. Cloning, okay, the first thing is we're cloning this, and oh, okay. So maybe I want to do this first. And we change directories here. Clear all outputs. All right, I'm just gonna try this and then we're wrapping up. Okay, run all. Oh, that didn't work. I need to get that right some other way. Not right now. Config path config. Model paths. So we do need that part, and that should go here. Okay, let's try once more. Okay, as a last recap, so we're trying to do experiments here, and we don't have at the moment an experiment folder, so this is running some stuff there, and I assume that this is gonna run out of RAM again, so I'm gonna go and close everything. Yes, leave, and yep, I'm gonna wrap up now. Let's see if this wants to work. Okay, so something worked there. So we're loading encoder waits. Loading the pre-trained StyleGAN, downloading AlexNet, downloading perceptual similarity, training with 100 samples. I don't think there's anything different with the RAM, so we're probably gonna get the same exact error. Okay, yeah, same exact error. So I'm gonna leave it here. We'll take a look, and we're going to just put this here. Everything out. Runtime error. CUDA out of memory. Try to allocate 1 gig. Blah blah blah. If reserve memory is allocated memory, try setting max split size MB to avoid fragmentation. See documentation for memory management and PyTorch CUDA alloc config. All right. This we're not gonna get up today, so I'd say let me go, and yeah, this is a wrap up. All right, I'll encourage you to support the channel by liking this video and subscribe if you wanna be notified when I upload new videos or when I go live next. I want to invite you also to the Discord server. You can go to that QR code or just to this URL to join us there. There's a lot of folks already interacting and sharing their projects and collaborating. And yeah, thanks a lot for watching, and I'll see you next time. Bye. Okay, behind the scenes. So Rob is saying if I have Colab Pro. I do have Colab Pro, and I don't really understand why this is. This was happening last week as well. So I need to take a look because this seems like it's only allocating 15 gigs of memory, whereas the notebook seems to have 25. And yeah, I don't know. I need to take a look at this. This was happening the other day with this algorithm as well. So it might be something of how the model is trying to allocate a memory to train. Yeah, I don't know. So again, thanks a lot for being there. I could try to work around the memory issue. Of course, yes. Let me share. Let me hide this 1 second. So I'm gonna share the notebook. Share. Get link. Only people can add. Chain to anyone with the link. Copy link. And all right. So I'm gonna show again. So that's gonna go. Thanks a lot, Rob, for that offering, and I'm gonna also put it on the Discord server. So I'm gonna close this now, and I'm gonna put the links here on Discord. I'll save these paths, right? So this is gonna be for live 49, and I'll go and put this on the live channel. So I made a little restructuring of these Discord channels just to make them a bit easier. Right, so maybe machine learning, I'm gonna post this error which I'm getting, and I don't know, maybe if you guys have time, as Rob said, hi all, here's the link to the Pixel2Style2Pixel Training notebook I was building during live 49, and the error I was getting from CUDA RAM memory allocation. So copy link, who's looking here, Rob, and there we go. Great. All right, I think this is it. I am going to leave. Oh, quickly an outro for our session. All right, this was one more session of the intelligence and sketching project. So I hope you enjoyed it. You can see a bunch more videos on machine learning and building an interface to interact collaboratively with drawings online. So this is the intelligence and sketching playlist. Thanks a lot for watching, and yeah, I'll see you next time. Bye. All right, and yeah, I think that makes it for today. Again, thanks for being there. Thanks Sajid, thanks Rob, thanks Juanda, Vitor, Bea, everyone who connected, and everyone who's watching after the fact. Let me know what you think on the comments. If you have any thoughts, any suggestions, or any ideas, I'll be super happy to hear about them.